bore everyone if you watched or listened to me do that. But what I'm going to do right now is I'm just going to eyeball the data and see if there's any better ones. And so one I might consider is humidity is equal to high, because there's an example right here. There's one here, sunny and high. Those are both play is equal to no. Sunny and high, play is equal to no. Oh, so we have 3 positive examples right here. If we scan the data set for other sunnies and high, there's no more. So we end up with 3 positive examples and a support of 3 for the antecedent. So once again, we're at 100%, but this one has more positive examples. 3 is more than 2. So this is what we would pick. And so now we have a rule that's 100% accurate. And so what PRISM does is then, oh, it's going to stop. We have a rule that we're going to keep. And so at that point, we need to go to the next step of the algorithm. And we kind of have to start all over a little bit with PRISM. So right now, if we think about what we have, what we're doing is we're building up a list of rules. And so our list of rules right now has one rule in it. It has the one if outlook is equal to sunny, and then humidity is equal to high, then play is equal to no. And so what we want to do now is we want to say, okay, well, which instances have we dealt with in our rule? We've dealt with this one, sunny and high, and then we have one more, sunny and high. The problem is we still have 2 instances right here where we haven't done anything. And so now what we have to do is we have to try to write down a rule that's going to cover these. And we want one that's 100% accurate. If we have one that's 100% accurate for these 2 instances, then we're done with the no's and we can move on with the yes. So what we do at this point, though, we have to do the same procedure over again. We have to say, okay, for this one, what are all the possible combinations? And so we start back over with a single antecedent rule. And so we're going to do if something, single antecedent, then play is equal to no. And we've already kind of gone down this route. We have to consider all 11 of the possibilities and that we get here. If we do, okay, if outlook is equal to rain, if we want to consider that antecedent, then we say, okay, here's one example, 2, 3, 4. So the support of that rule, the support of the antecedent is 4. There's 2 positive examples. So we get 50% accurate. Okay, so at this point, what we're trying to do is we're trying to get these other 2 examples covered. And so what I want to do is I want to blank the screen, and I kind of want us to consider all the possibilities that are in play at this point. And so the instances we're dealing with are the ones left over where the outlook wasn't sunny and we had the other thing is equal to being true. And so we already considered the possibility that outlook is equal to rain, and we saw that that gave us 50% accuracy. And so if we look at this, we're dealing with just these 2 instances. That's the only value that outlook takes on for those 2. So we have one possibility to consider there. If we look at the temperature, we have either temperature is equal to cool or temperature is equal to mild. So there's 2 possibilities to consider there. And then with humidity, we have normal or high, 2 possibilities. And with windy, we only have one possibility, true. So we have to consider 6 possible rules in this case. And so notice this is down from 9. This is the way PRISM works. Once we've already dealt with the other 4 no instances, then, the other 3 no instances, then we don't consider all the features that led to those rules. And so then if we wanted to keep on going, if we want to consider the 2 temperature features, cool and mild, and so if we look at those, what we do is we deal with only these instances to decide which rules to consider, but then when we count up the positive examples and the support, we still deal with the entire data set. And that's because we have to know things like false positives. We have to know those things for the accuracy. And so when I look at temperature is equal to cool, I see, okay, there's one case where we get temperature is equal to cool and play is equal to no. So one positive example. But out of the whole data set, that antecedent has a cover of 4. And so we get 25% accuracy. That's not too good. If I do the same thing for mild, 2 positive examples out of the whole data set and a support of 3 for the antecedent. 66% accuracy. So better than outlook is equal to rain, but it's 66%. If we keep on going, then we also have to consider humidity, and we have to consider 2 possibilities, normal and high. And so I'm trying to streamline what I'm writing down, but remember we're looking at the whole data set. So out of that one positive example where humidity is equal to normal, play is equal to no, but a support of 4, so 25% accuracy. Now we get humidity is equal to high, 4 positive examples out of 6, so 66% accuracy. That's just as good as we had with if temperature is equal to mild, but there's more positive examples. More of the data set is covered. So right now, this is our current champion, 66% accurate, 4 positive examples. The last 2 to consider, windy is equal to false, and then windy is equal to true. So if we look at that, 2 positive examples that are false out of a support of 6, so 33%. This is not a new champion. True, though, we get 3 positive examples out of 4, 75% accuracy. So this is the rule that we're going to go with, if windy is equal to true. So what we're doing is we're following through with the PRISM algorithm, and we got to the point where we have a rule that, that's a horrible mark, isn't it? If windy is equal to true, then play is equal to no. But that's not 100% accurate, so now we have to go through the whole rigmarole again, and now we have to find another antecedent. So if windy is equal to true and another feature is equal to a value, then play is equal to no. And our goal is to get 100% accuracy, and what we're dealing with are the instances windy is equal to true, play is equal to no, right here. And then we also had these other ones, true and no. And then we had a false positive, right? 75% accurate. So here's the true and yes one. So what we want to do is we want to look at these and we want to say, okay, well this one we know we already kind of covered with the outlook sunny rule. And what we want to do is we want to say, okay, is there anything in these that we can find? Oh, well actually here's the answer. If outlook is equal to rain, and windy is equal to true, then don't play. That covers both of these. That's going to be 100% accurate, and that's where we would stop. But what we have to do is we have to consider all the possibilities. So 2 for outlook, sunny and rain. Temperature we have to consider hot, cool, and mild. So 3 possibilities there. Humidity high. So there's only 1 possibility to consider. And that one would actually give us no new information, so that one's going to be out of play. And then windy is off the map, off the table. It's not in our data set because we already have it as an antecedent. So if we consider these 6 possibilities, the one that's going to give us 100% accuracy, and in reality for PRISM, remember, we have to look at them all, but this one can be eyeballed because the data set is small enough. We're going to consider this. And so we get 2 positive examples out of a support of 2. We get 100% accurate. And so 100% accurate is where PRISM always stops. So now we have a second rule in our rule list. We have 2 rules in the list, and those 2 rules together cover all of the play is equal to no instances. And so that's when we're stopped dealing with play is equal to no. What PRISM says then is after that, we want to do the whole thing over for the play is equal to yes instances. And that's what you guys are asked to do for your homework.